Next method of separation of components of mixture is fourth method, separation of two immiscible liquids. When two immiscible liquids are there, how to separate these two liquids? Immiscible liquid means the liquids which do not mix into each other. The liquids which do not mix into each other are called immiscible liquids. So if they are not mixing up into each other, that means these kind of mixtures, these are heterogeneous in nature. Example of immiscible liquid is we can take water and oil, we can take like water and kerosene oil. This mixture is of two immiscible liquids. How we can separate these two components? The apparatus that we use for this is a separating funnel, and the method is also known as separating funnel method. What is a separating funnel? It is a flask which is narrow at the top, then widens up in the center and again narrows down at the bottom part. Like this, and there's a stopcock here to open or close it. In this separating funnel, we take the two liquids that we want to separate out. Since the liquids are immiscible, they will form the separate layers. One liquid is this one that I am drawing with a blue color, and let's say the second liquid is this yellow color liquid. So we can see the two separate layers of these two. So one is a water and another one is oil. Though they are forming separate layers, but it's not easy to separate them just by removing with a spoon and all that. So what we have to do here is we will take this separating funnel. In this separating funnel, which liquid will be at the bottom part? The one which is heavy. And out of oil and water, water is heavy. So kerosene oil will be at the top of this because it is lighter than water. This is separating funnel. And this is a stopcock to open or to close this. And at the top we have a cork to close this. So after taking this mixture, we'll close the separating funnel and we have to shake it and leave it for some time. After shaking it and leaving it for some time, when we open this stopcock, before opening this, we'll keep an empty beaker under this. When you open the stopcock, which liquid will start coming out? Of course, the water will start coming out because it is at the lower part. So this water will start collecting here in this beaker. So water will be here. And close this stopcock quickly as the oil reaches near to this stopcock. So quickly we have to close this stopcock. So what will be here in this water and what will be left behind in the separating funnel is only kerosene will be left behind. Now in this method, can you tell me which principle is used here in this method? Can you just think about the principle that is used in this method, how we are able to separate the two liquid layers? The reason is because the densities of two liquid layers, they are different, so that is why it is possible to separate them. High density liquid will be at the low level and the low density liquid will form an upper layer. So principle behind this thing is that we are able to separate them based on their densities. Depending on their different densities, it is possible to separate them. So this is our fourth method to separate the two immiscible liquids. When the liquids are not miscible into each other, how we can separate the two using a separating funnel. Now, fifth method after this is the chromatography method. Chromatography. This method we are using to separate different colors which are there in an ink, colors, or to separate components of ink. A mixture we have in which there are components which are colored or to separate the components of ink, we are using which method? Chromatography method. Now first of all, this chromatography, this is from the word chroma. In Greek, chroma means color. Chroma means color. And graphy. Chromatography. Chroma and graphy. Graphy means writing. Because the method was actually first of all used to separate the colored substances only. However, now this technique is widely used for separation of both colored and colorless components of a mixture. But initially it was just used for the separation of colored components. Chroma means color. That is why it got the name chromatography. But nowadays we can use this technique to separate colored as well as colorless components of a mixture. Now the principle of this method is that different solubilities of components. Components have different solubilities in the same solvent. One dissolves more, another one dissolves less in the same liquid. Based on this property of these components, we are using this technique. Now, how we'll separate, we are taking black ink here. How we can separate the components of a black ink? The procedure for this method is, we'll take a thin strip here. Thin strip of chromatographic paper we will take here. It's just like a filter paper, only a special kind of paper that is called chromatographic paper. A thin strip of this chromatographic paper we will take. With the help of pencil here, we will make a mark. Approximately you can say about 3 centimeters above the lower edge. Approximately at this we will make a mark with the pencil. Now we'll take a mixture and take a drop of that and of the water soluble black ink we are taking here and put that here on this pencil mark on the center of this line with the help of dropper, and then let it dry. After this, what we'll do is we'll take this chromatographic paper and suspend this paper in a jar. Glass jar we will take, and in this glass jar we will suspend this chromatographic paper with the help of thread. And then we have to, before closing this thing, we have to take water here in this. In the jar we are taking water. That liquid we have to take in which the components of this ink, they are soluble. So suspend the filter paper strip, or you can say the chromatographic strip, in a gas jar which has some water in it. But when we are suspending this chromatographic paper in this level of water should be below this ink mark. It should not, this ink should not dip into the water. The ink spot should be above the level of the water. Now after this, what we will see is that in this jar, leave it for some time. And on the chromatographic strip, now what we will see, this ink mark here that we have taken, slowly and slowly water will be absorbed by this strip, and this water will rise up, reaches near to this ink mark, and the components of ink, they will start dissolving in this water. And remember, the solubilities of components of ink is different in this. Some are dissolving more in the water, some they will dissolve after some time. So slowly and slowly water is rising up, and the components slowly and slowly will dissolve in the water, and with water they will rise up. So that component will reach on the top part, the one which is more soluble in the water. So suppose that component is this one of pink color, and it has reached the top part along with the water, and some of the dots we'll see here at the low level, at different heights we will see this thing. and here what we have is the water. So there are suppose three components in this, all have different solubilities in water. Slowly and slowly with water they are rising up, and at the top part which component will be there? The one which is more soluble in water. So water rises up, and along with this it is taking all the colored components which are called dyes along with it. This is a, labeling it again, spot of black ink. This is a pencil mark. This is a strip of chromatographic paper, or we can take, I told you, is filter paper. Better results will be if we take a chromatographic paper. Now we'll remove this strip from the jar. When we'll take out this strip, what we see on the strip is different components are here. This is the blue one here, black one, and then I had drawn the pink color here. So different colored components are here. These are different dyes present in black ink. In black ink these dyes were there, and with the help of this method they got separated. So this is the method that we use to separate mostly the colored components from a mixture, but this can be used even for the colorless as well as for the colored components nowadays. Chromatographic paper is taken here, and on this paper we'll take a drop of the mixture that we want to separate into its components. So see, in this method just a drop of mixture we are taking. So that means this method can be used only if the mixture that we want to separate into its components is in very less amount. So just a drop is there, and like this we can separate the components. The principle behind this method is the components here, they have a different solubilities in the same solvent water, but the components, they have different solubilities. So this is a fifth method, that is the chromatographic method. After the chromatographic method, moving on to the next method, the sixth method is a separation of mixture of two miscible liquids. Now we are taking the liquids which are soluble into each other. That means this mixture is homogeneous in nature. And the method that we use to separate these two liquids is called simple distillation method. This is called simple distillation. Now first of all, what is the meaning of distillation only? Distillation means changing of a liquid to vapor. How? By heating, of course. We change the liquid to vapor by heating, and after that what we have to do to these vapors is we have to condense these vapors, and vapors we can condense only by cooling. So first we'll heat the mixture, and then after that we have to cool it. Now the principle in this method is the components that we want to separate here, the liquids which are miscible, they have a large difference in their boiling points. Large difference in the boiling points of liquids. Approximately 30 to 50 Kelvin temperature difference should be there, boiling point difference should be there. Now operators that we need for this method is, we will take here a distillation flask. A distillation flask is taken, but that flask we have to mount on a stand. We have to clamp it. This is the stand that we are using, and then we are taking a tripod stand because we have to heat the mixture. So on the stand, tripod stand, we'll take a wire, a net is here. On the net we are keeping this flask. This is a round bottom flask. Then we will have a thermometer also here to note down the temperature. This side is a small opening through which we will attach a condenser. We are attaching a condenser here. Around this we have a jacket through which the water will enter, the cold water will enter from this side. It will move in this jacket, and from this side the hot water will come. So there is a water outlet here, and from this side the cold water enters. Other end of this condenser, under this we will keep an empty beaker, and then we have to heat this mixture. So when we heat it, there are two components here. Let's say this is a mixture that we have here. On heating this, there are two liquids in this, and the large difference in the boiling points of these liquids. What will happen on heating? First, that liquid will start changing into the vapor form, which has a low boiling point, and this liquid vapors will come into this condenser. And when these vapors will come in the condenser, when the cold water will fall on this thing, the vapors will condense in this, and the vapors will change to liquid form. This liquid is collected in the beaker here. So which component will come in the beaker? The one which has a low boiling point, and another component which has a high boiling point will remain here in this flask. Let's say the mixture that we have taken here is a mixture of acetone and water. Mixture of acetone and water we are taking. Acetone boiling point is 329 Kelvin and water boiling point is 373 Kelvin. So which component will change to vapor form? First of all, acetone. So here acetone vapors will come. So which liquid will get here in this beaker is acetone. And which component will be left behind here in the flask? That is the water. So this flask that we are taking here, this flask is known as distillation flask. So by doing distillation, distillation means by heating and cooling we can separate the components. This is a clamp. This is condenser, water condenser. This is apparatus that we use for this purpose, that is to separate the two miscible liquids from each other. The method used here is known as distillation method. And the principle behind this method is there should be a large difference in the boiling points of the liquid.